Alright, today we are doing 6.2 inverse trig functions. We're going to go backwards, guys. We're going to figure out what degree makes the value. So at the first part here, it just reminds you of what inverse actually means. So to find an inverse, we switch x and y, and we solve for y. So if we were to find the inverse of sine x, I would switch x and y and then solve. Of course, to get rid of the trig function and only keep y, you would do the inverse trig function. These are other ways to represent the inverse trig. Arc sine, arc cosine, arc tangent. You'll see these mostly during calculus, but for now we're going to use the inverse. Many of you have dealt with the inverse functions before, but remember, we are doing this without a calculator. So make sure you have your unit circle handy. And now we're going to work backwards. Okay, so first of all, if you remember, if you talk about a function, that means that it will do a vertical line test. Okay? An inverse function, we flip x and y. But as you can see, if we flipped x and y here and we turn this graph, we would no longer have a function because you cannot do the vertical line test. So if you remember correctly, when you think of inverse on a regular graph, you can do the horizontal line test. So what they did to make sure this is able to work is they restrict the domain for sine. So for sine, we're restricting it from pi, negative pi over 2 to pi over 2. So right here where it is darkened. Okay? Which also means that we are only using quadrant 1 and 4. And this is the graph of that restriction. For cosine, as you can see, we can't go from negative pi over 2 to pi over 2 because we would still not have a function. So we have to restrict it from 0 to pi. Okay. If you look at your unit circle, 0 to pi is quadrant 1 and quadrant 2. So just to remind you, on your unit circle, we are using for sine, we are using quadrant 1 and 4. For cosine, we are using quadrant 1 and 2. Now let's look at tangent. Tangent, we also have an issue, but we have to restrict it from negative pi over 2 to pi over 2, which again, like sine, has us do quadrant 1 and 4. So on your unit circle, you are only looking at these two quadrants. What does that really mean? You'll see in about a minute. I'm not going to have you write down quadrant 1 just for the fact that you should have your unit circle with you. Okay. Alright, so what do these questions look like? What we're going to do is find the exact value without a calculator. So we want to find out where sine would equal to square root of 2 over 2. Okay. Pull out your unit circle. Now, think of your domain. We only use quadrant 1 and 4. So I'm going to cover this up. If we're looking for the square root of 2 over 2 for sine, remember that the coordinate sine is in the second place. So where is the only place that we have square root of 2 over 2 for the second coordinate. Right there. We're always going to write these in radians, so the radian is pi over 4. B. We have sine again, so cover up that left side. And when we're looking for a negative square root of 3 over 2. So, cover up the left side, look for a negative square root of 3 over 2. Right there. Everybody find it? Now, of course, you're tempted to write 5 pi over 3. But here's the issue. If I start at 0 and I went to 5 pi over 3, I would be going counterclockwise to get to 5 pi over 3. That's 300 degrees. But what happens is we run into the domain restriction. That's why I have you guys put your hand there. So how do we get here without going into my hand? Well, the way to do that is to go counterclockwise. So we got to figure out what is this degree going backwards. Last class we learned about negative the degree or negative the radian. So if we look and we reflect, 5 pi over 3 is same thing as pi over 3. But since we are going counterclockwise, it is going to be negative pi over 3. Again, it's because we cannot go counterclockwise. We have to go clockwise, which makes us go backwards. All right, let's practice some cosine. Cosine, what quadrants do we look at? Hopefully, you said quadrant 1 and 2. So we're covering the bottom. Okay, we're covering the bottom. We want to find where it's 1/2. So, cosine is what part of your coordinate pair? It is your first one. So, where is it 1/2? Positive 1/2. It is positive 1/2 right there at pi over 3. Okay, cosine negative square root of 2 over 2. Cover that bottom. First coordinate, negative square root of 2 over 2, right there. Now 3 pi over 4. Remember what sign we ran into that we couldn't go counterclockwise because we ran into the domain restriction? Well, here, if we go to 3 pi over 4, did we run into a problem? Nope, I could get there just fine. So my answer is 3 pi over 4. All right, tangent. Now to do tangent, guys, you really want to have your tangent stuff down. So what I would do is quickly copy my unit circle, and as you can see, I put my tangent stuff on the outside. Undefined, negative square root of 3 over 3, negative square root of 3, negative 1, negative square root of 3 over 3. This is 0. Square root of 3 over 3, 1, square root of 3, undefined, negative square root of 3, negative 1, negative square root of 3 over 3, and 0. Because if you remember, tangent is sine over cosine. If you have to do that, go back, pause the video, and write those down. But right now I'm going to continue. So we're going to find where tangent is 1. So, tangent. Do you remember what sides that you cover up? Tangent only uses 1 and 4. So I'm going to cover up that left side. And again, I'm looking for the value of 1. There it is. I want to make sure. Yep, we're good. So it's 1 right there. Where is it 1? Pi over 4. Next one. Negative square root of 3 over 3. Alright. Find negative square root of 3 over 3 on your unit circle. I found it right here. Now, that's 11 pi over 6. But we run into that situation like we do with sine. If I went to 11 pi over 6, I run into my hand. I run into that domain restriction. So actually, I have to go clockwise to get there. So the question is, how much did I go clockwise? I can look at the reflection. This radian is the same thing as this radian. Same place. But of course, instead of going positive that way, I'm going to go negative. So it is negative pi over 6. Okay, now we're going to do compositions involving inverse trig functions. So what we want to remember here is we are doing 2 functions. So you see 2 steps. Now with that, I want you to remember to work from the inside out. And try not to do this in one step. We want to do the inside, then do the outside. Okay? So first of all, when I'm looking at cosine 7 pi over 6, this is finding the exact value. We do not have to cover up in this case because there's no inverse to it. So I'm doing the inside first. I'm not going to do that inverse first. So I'm just doing the exact value. So find 7 pi over 6 on your unit circle. And I find it right here. Cosine, again, is the first part of the coordinate. Sorry, not quadrant, coordinate. So we get negative square root of 3 over 2. So right here, cosine 7 pi over 6 is negative square root of 3 over 2. That is the value of the inside. So now we're going to do the outside. The outside is where we have that inverse. That is where we cover up. So I'm going to cover up, cosine is covering up the bottom. I'm going to find negative square root of 3 over 2 in the first part of the coordinate because it is inverse cosine. Okay, so if I go along, I find that it's right here, and the radian is 5 pi over 6, and it is okay because we don't have it in our domain restriction. So we get 5 pi over 6. All right, let's do the same thing with tangent. So again, we're going to do the inside first. So tangent, there's no inverse, so I use the whole unit circle. Find tangent of pi. Well, here's pi. Okay, if you wrote this down, we would have 0 over negative 1. Well, 0 over negative 1 is 0. Okay, again, tangent is sine over cosine, so 0 over negative 1. 0 over negative 1 is the value of 0. So that's the inside. The outside is our inverse. Now we have to cover it up. So cover up the left side of our triangle and find where it is 0. 0, 0, 0. Right here it's 0. That's undefined. So this one's 0 right here. So remember, sine over cosine, 0 over 1 is also 0. So what degree do we have, or what radian do we have? Now for this spot we have 2 of them, but I want you to recognize if we did 2 pi, we would be going around the whole circle, which means we would be running into that domain. So our answer will be 0. Okay. Now we have sine inverse sine pi over 4. Okay, so first we're going to do the inside, which is sine pi over 4. So find pi over 4. Sine is the square root of 2 over 2. So that was of our inside. Now we are going to do the inverse. So let's keep in mind that for the inverse, we have to think about covering up a side for domain restrictions. When you cover up a side and you find square root of 2 over 2 in sine, you find that it's in right there, and we're in the same spot, pi over 4. Pi over 4 is okay, right, because we don't run into our restriction. Now, I want you guys to recognize, yes, in this case, it happened to be that it was the same answer. But we don't always come out that way, right? Because as you can see with cosine and cosine, we had 2 different ones. This is because of domain restriction. So make sure you are always doing the inside and then the outside. So remember, 2 steps. Okay, the other example I want to show you, there's a couple more I just want to show you. Your inverse does not always have to be on the outside. I could say sine of sine inverse, let's say negative square root of 2 over 2. I would still do the inside first. Now with the inside, because it is the inverse, I have to do the domain restriction. Okay? Another example that you could do is what if you had 2 different trig functions. So let's say I have sine inverse of cosine, let's do 2 pi over 3. We can still do this. You want to do the inside out. Let's actually finish this problem. If we did cosine of 2 pi over 3, 2 pi over 3, cosine is the first part of the coordinate, so it's negative 1/2. So we get sine inverse of negative 1/2. Now again, because it's inverse, because of that negative 1, we have to do domain restrictions. Sine, you cover up the left side. And then we're finding, in this case, remember we're finding sine, which is the second part of the coordinate. So sine negative 1/2 is right down here at 11 pi over 6. But of course, I can't put down 11 pi over 6 because it starts at 0 and 11 pi over 6 goes around the whole circle. And I run into that domain. So actually I have to go clockwise, which means I'm only going this far. So what is that same reference angle? Well, I can reflect it. It's pi over 6, but of course, because we're going backwards, it is now going to be negative pi over 6. Okay, so my biggest things with compositions, guys, is to do it in 2 steps. All right, go grab your work and start your practice.